So good morning friends. So this is my next lecture on the same topic, that is the chemical thermodynamics. Okay. Today we are going to discuss the next point from the topic, that is the enthalpy change in physical transformations. As far as enthalpy change in physical transformation is concerned, before that you have to know first what is meant by physical transformation and what is meant by chemical transformation, isn't it? That is, in short, we say that physical change and chemical change, isn't it? So as far as physical change is concerned, physical change are concerned, or chemical change. As far as physical change is concerned, in physical change what happens? Yes, physical changes are those changes in which there is only change in physical state occurs without change in chemical composition. Just if I take an example, that is, suppose A is in the liquid state. Okay, A is in the liquid state, and if suppose changes, or suppose if I say one particular example I will take, suppose H2O suppose in the solid state. H2O in the solid means ice is there, and if it converts into H2O liquid, then in this case solid is converted into liquid, means physical state changes. One physical transformation occurs without changing chemical composition. H2O in solid state also possesses same chemical formula, chemical composition. Water in liquid state also possesses same chemical composition. So in physical change there is only physical state changes, means solid to liquid, liquid to gas, solid to gas, okay, gas to solid, gas to liquid, in this way, isn't it? And chemical changes, there is a change in chemical composition. Okay, chemical composition जो असतो, that is a chemical composition change. Best example, suppose if you consider calcium carbonate solid, it converts into calcium oxide solid, plus suppose that is a carbon dioxide gas. It is a solid state, it changes into one solid and one gaseous, means there is a chemical composition. Calcium carbonateचं chemical composition जे आहे ते राईट साईडमध्ये जर बघितलं तर कॅल्शियम ऑक्साईड आणि कॅल्शियम कार्बन डायऑक्साईड. सो केमिकल कंपोजिशन changes one. Doesn't matter, it may physical state remains same or changes one. Don't bother about that, just chemical change occurs, it is chemical transformations. Okay, so now we are going to discuss the enthalpy change in physical transformation. Like this support reactions, during that course whatever enthalpy change occurs we are going to study. Okay, so as far as enthalpy change in physical transformation is concerned, the physical transformation you know, okay, just now. So first point, that is enthalpy change in physical transformation, that is the enthalpy change in phase transition. Enthalpy change in phase transition. So as far as enthalpy change in phase transition is concerned, that first, again, phase in the sense, again we are going to discuss physical state here. Phase in the sense physical state one. So physical transition, physical state बदलत असताना होणारी enthalpy change. So that first we are going to discuss the enthalpy change in fusion. Enthalpy change of fusion. Is also represented by delta fuse H, represented by symbol delta fuse H. Okay, enthalpy change in fusion means delta H is the enthalpy change, and what type of enthalpy change or what process physical state change is there? Fusion is there. So as far as enthalpy change of fusion is concerned, so before that we are going to discuss the definition of enthalpy change of fusion. First, in that particular process, which physical state is converted into which physical state, means rather than solid to liquid, liquid to gas, or any of these ones. So just fusion in the sense, yes, fuse honing is okay. Fusion in the sense there is a, yes, what happens? Solid fuses, solid melt, solid fuses or solid melt होते, in the sense, yes, solid is converted into liquid state. So as solid is converted to liquid state, in the sense there is the enthalpy change accompanying the process in which, definition is see there, the enthalpy of fusion is defined as nothing but enthalpy change accompanying the conversion of 1 mole of solid substance into its liquid state at constant temperature and without change in pressure. Without change in pressure. At constant temperature without change in pressure. ओके, टेम्परेचर कॉन्स्टंट असताना आणि प्रेशरमध्ये बदल न करता जर एक मोल सॉलिड सबस्टन्स त्याच्या लिक्विड स्टेटमध्ये कन्वर्ट होत असेल तर त्या केसमध्ये होणारी एन्थॅल्पी चेंज वी कॉल ॲज अ एन्थॅल्पी ऑफ फ्युजन. We call as the enthalpy of fusion. So once again, enthalpy change of fusion, it is not simply enthalpy of fusion is nothing but enthalpy change accompanying the conversion or process of conversion of one mole of solid substance into its liquid state at constant temperature without change in pressure. We call as the enthalpy of fusion. Okay. Now enthalpy of fusion is solid is converted to liquid. Solid is converted to liquid. So if we take an example, suppose H2O solid is converted into H2O liquid. H2O solid is converted into H2O liquid. So in this case, the enthalpy change occurs. There is the enthalpy of fusion, delta fuse H, and in this case the enthalpy was just guess the sign of delta H, whether it is positive or negative. Yes, solid is converted to liquid in the sense in solid state, in solid ice, the intermolecular force of interaction between two water molecules has to be broken and it converts into liquid state. So has to be broken in the sense we have to supply the energy. So we have to supply energy and it is positive. It is positive. So it is plus 6.01 kilojoule per mole at 0 degree Celsius. At 0 degree Celsius. Okay, at 0 degree Celsius, the 6.01 kilojoule, this much amount of energy is to be supplied to water, 1 mole of water, ice, to convert into liquid. Okay. So nextly, immediately, if we reverse this reaction, means suppose if H2O liquid is converted into H2O suppose solid, H2O liquid is converted into solid one, then what is the process of conversion of liquid into solid? Yes, it is the freezing. So as freezing process, in the sense during that course enthalpy change occurs. There is delta freeze H. So enthalpy of freezing in this case, again definition is the same. Enthalpy change accompanying the conversion of 1 mole of liquid into its solid state, okay, at constant temperature without change in pressure. It is called an enthalpy of freezing. And here as the process is reversed, that's why value of freezing must be same amount but sign is opposite. So it is minus 6.01 kilojoule per mole at 0 degree Celsius. So it is minus 6.01 kilojoule, means during the conversion of water H2O liquid to H2O solid, that is enthalpy is negative in the sense bond formation takes place. Intermolecular force of attraction becomes strong and strong. So here weak and here strong. So weak to strong, there is a heat energy released because bond formation process are always endothermic, bond breaking process are always endothermic. Okay. So this is the enthalpy of, it is the freezing. Then next, we are going to discuss the next enthalpy. It is the under the same point, there is enthalpy change in phase transition. The next point, it is the third one. It is the enthalpy of solid to liquid, is it liquid to now gas. There is the enthalpy of vaporization, delta vap H, enthalpy of vaporization. So as far as enthalpy of vaporization is concerned, in vaporization what happens? Yes, liquid is converted into gaseous state. So as liquid is converted to gaseous state, the definition is the same. There is enthalpy change accompanying the process or conversion in which 1 mole of liquid substance is converted into gaseous state at constant temperature without change in pressure. It is called as an enthalpy of, that is the simply vaporization. It is called enthalpy of vaporization. And as far as enthalpy of vaporization is concerned, suppose liquid H2O is there. Okay, H2O liquid is there and it is converted into H2O gaseous state is there. In this case, delta, that is the vap H, enthalpy of vaporization. This enthalpy of vaporization, as far as concerned, it is in first case, means it is given in the at 3 different temperatures. One at first temperature, it becomes, that is the 45.07 at kilojoule per mole. Unit is the same, kg per mole at 0 degree Celsius. Same enthalpy of vaporization, that is the at 25 degree Celsius and it is given at 100 degree Celsius. Now just if you consider, as temperature increases, means 0 degree Celsius the enthalpy of vaporization for conversion of 1 mole of liquid into gaseous is plus 45.07. It is plus 45.07. In the sense, this much amount of heat energy has to be given to 1 mole of liquid. Okay, at this constant temperature, 0 degrees Celsius, then it converts into H2 gas. Then it converts into H2O gas. So if we just guess the values of enthalpy change at 25 degrees Celsius and 100 degrees Celsius, at 100 degrees Celsius, we don't know the exact values but at least we have to know whether trend is either decreases with increase of temperature or increases with increase of temperature. Yes. So as 0 to 25 degrees Celsius, temperature increases. So temperature increases in the sense internal energy or whatever the internal energy associated with this liquid water is initially more in that at 25 degrees Celsius. So as initial temperature is more in the sense for the conversion of that high temperature liquid to gaseous state, external energy or extra energy we have to supply at 25 degrees Celsius. Obviously it is less than 0 degrees Celsius. It must be less than 0 degrees Celsius, and this is found to be, it is plus 44.0 kilojoule per mole at 25 degrees Celsius. At 25 degrees Celsius, and still decreases at 100 degrees Celsius. It is just about plus 40.0, I think 7 kilojoule per mole. 40.07 kilojoule per mole. This much amount of energy has to be supplied at 100 degrees Celsius for the conversion of 1 mole of liquid into its gaseous state. 1 mole of liquid into its gaseous state. Okay. So this is about the enthalpy of vaporization. Enthalpy of vaporization. Now immediately, if we take the next, just reverse the process. Reverse the process. That is the H2O gas. Suppose it is converted into H2O liquid. H2O liquid. Gaseous conversion liquid. That process is called condensation. That process is called as a condensation. So a condensation in the sense, it is the delta condensation H. Delta condensation H. That is the enthalpy of condensation or enthalpy change of condensation. Similar definition is there. There is the enthalpy change of condensation, or enthalpy of condensation is nothing but it is the enthalpy change accompanying the conversion of 1 mole of gaseous substance into its liquid state at constant temperature without change in pressure is called as an enthalpy of condensation. Enthalpy of condensation. Actually, these values are opposite in sign that of the vaporization. जर लिक्विड पासून गॅसियसला एन्थाल्पी ऑफ व्हेपोरायझेशन 0 डिग्री सेल्सियसला प्लस 45.07 असेल, तर गॅस पासून लिक्विडला at same degree Celsius temperature, same amount, it should be opposite in sign only. So it is at 0 degree Celsius, it is minus 40.07 kilojoule per mole. Now see, minus in the sense exothermic bond formation. Gases मध्ये molecules are very away from each other, water molecules. But in liquid state, there is a slight intermolecular force of interaction increases from gases to liquid one. So as bond formation process increases, okay, when it passes from gases to liquid, therefore it is exothermic, heat energy is released. Heat energy is released, and same temperature it should be just sign is reversed. Sign is reversed. This is enthalpy of vaporization. The next, that is the if you consider, that is the next point, it is the phase transition मध्ये, and it is the last point in phase transition. That is the enthalpy of sublimation, delta sub H, enthalpy of sublimation. So as far as enthalpy of sublimation is concerned, enthalpy of sublimation. So as far as enthalpy of sublimation is concerned, as far as sublimation process is concerned, what is sublimation? Yes, the process in which the solid substance is converted into liquid state, into the gaseous state without change in liquid state. जर एखादा सॉलिड सबस्टन्स त्याच्या गॅसियस स्टेटमध्ये कन्वर्ट होत असेल विदाउट अटेनिंग लिक्विड स्टेट, दॅट प्रोसेस इज कॉल्ड एज सिम्पली सबलिमेशन. जर एखादा सबस्टन्स सॉलिडपासून डायरेक्ट गॅसमध्ये पास होत असेल विदाउट, दॅट इज द मिडल स्टेप, दॅट इज गॅस लिक्विड स्टेट. लिक्विड स्टेटमध्ये न कन्वर्ट होता डायरेक्ट तो सॉलिडपासून गॅसमध्ये असेल, तर दॅट प्रोसेस इज कॉल्ड एज, इट इज द सबलिमेशन प्रोसेस. दॅट्स द प्रोसेस कॉल्ड सबलिमेशन प्रोसेस. सो सिम्पली अगेन सबलिमेशन प्रोसेस. यस, H2O suppose solid state, and if it converts into H2O suppose gaseous state, then in this case the enthalpy of sublimation is found to be, that is the delta sub H, and delta sub H, it is plus 51.07 08 kilojoule per mole. Okay, 51.08 kilojoule per mole. Now remember well, when 1 mole of ice, liquid water ice state मधला 1 मोल त्याच्या गॅसियस व्हेपरमध्ये कन्वर्ट करण्यासाठी सब्लिमेशनची अमाऊंट जी आहे ती 51.08 किलोजूल पर मोल ॲट 0 डिग्री सेल्सियस. At 0 degree Celsius. Okay, means this much amount of heat if you supply to ice, okay, it converts into, that is the gaseous state. Gaseous state. Is it? Gaseous state. Now, if you consider enthalpy of sublimation, Before that, just I would like to explain one point. That is the first. Suppose this process solid to liquid directly converts. So instead of this, if I convert this H2O solid to suppose H2O liquid state. Suppose in first state, it converts into H2O solid to H2O liquid state. So conversion of H2O solid to liquid state, yes, it is which type of process is there? The solid is converted into liquid. So it is enthalpy of fusion. It is delta fuse H. Enthalpy of fusion. And for conversion of 1 mole of solid into liquid state without change in pressure at constant temperature, the value of enthalpy of fusion is found to be, it is a plus 6.01 kilojoule per mole. Plus 6.01 kilojoule per mole. हे आपल्याला माहिती आहे value, just we studied already. Now in second step, if I convert this H2O liquid by second step process, it converts into gaseous state. Now conversion of liquid to gas, which type of process is there? Liquid's conversion gaseous मध्ये केलं. It is enthalpy of vaporization. That is delta vap H. And this enthalpy of vaporization ची value for conversion of 1 mole of liquid into 1 mole of gas is found to be, yes, just we studied already. That is 40. Yes, solid or liquid, positive or negative. Solid is conversion gases मध्ये, so it must be bond breaking processes there. So it is 45.07 kilojoule per mole. 45.07 kilojoule per mole. This much amount of energy has to be supplied. Now if you consider that is the H2O solid is converted directly into gas. The process is called as sublimation, and during that course the enthalpy change occurs. That enthalpy is called as an enthalpy of sublimation, whose value is 51.08 kilojoule per mole. Is it? So it is a direct state. This process is the direct conversion from solid to gaseous. But instead of that, if I convert this solid into first liquid state by the process of fusion, and in that case the enthalpy of fusion value is 6.01 kilojoule per mole. And after that, if liquid is converted into gaseous phase मध्ये, that by the process of vaporization, and in that case the enthalpy change occurs, value is 45.07 kilojoule per mole. So this is indirect process. This is direct. So this whole process is found to be indirect process. Okay, indirect process. Okay. So if you just consider the values, this is a direct process and this is indirect process one. So indirect process, whatever those process, that is H2O solid to H2O liquid. H2O solid is converts into H2O liquid process. By the process is called as an enthalpy of, that is the fusion, first process. And second process, that is the H2O liquid is converted to H2O gas. H2O liquid is converted to H2O gaseous state by the enthalpy of fusion, vaporization. If I add these two reactions, one H2O liquid is in the right hand side, it is in the left hand side. So this cancel. In the left hand side only H2O solid is there. It converts into right hand side. H2O gas is there. So just H2O solid is conversion liquid. Delta fuse H. Liquid is conversion gas. Delta vap H. And solid is conversion gas. Delta sub H. In the sense, what it indicates? This process indicates that जर एखादी प्रोसेस चेंज डायरेक्ट एका सिंगल स्टेपमध्ये झाल्यानंतर होणारी एन्थाल्पी चेंज, आणि तीच प्रोसेस किंवा तीच चेंज जर इनडायरेक्टली 2 किंवा 2 पेक्षा जास्त स्टेपमध्ये फॉलो केला, तर दोन्ही पण प्रोसेसमध्ये होणाऱ्या एन्थाल्पी चेंजची व्हॅल्यू काय असणार? इट इज द सेम. ॲक्च्युअली इट इज द ॲप्लिकेशन पार्ट ऑफ द हेस लॉ ऑफ कॉन्स्टंट हीट समेशन. द लास्ट but somewhat next part of this topic one, but it is the application of Hess law of constant heat summation 1. So in this case the value is 51.07, and if you add these two values, that is a 6.01 and 45.07, then value becomes, it is again 51.08. 51.08 means if you transfer H2O liquid directly into gaseous state, enthalpy change remains same. Or if you transfer H2O solid into liquid and then into gas, in these two processes, the enthalpy change, if you add, again the value becomes same, it is 51.08. Okay, so it is the enthalpy of sublimation. It is the enthalpy of overall sublimation. Actually, it is the application part of the Hess law of constant heat summation. Then it is the enthalpy change in physical transition process or part is completed over. Now next part, there is the enthalpy change in atomic or molecular changes. Enthalpy change in atomic or molecular changes. Atomic or molecular changes. Enthalpy change in atomic or molecular process. Okay. Now see here, enthalpy change in atomic or molecular process. In this case, we are going to discuss, that is the first point, that is the enthalpy of ionization. That is the delta ion H. Delta ion H, enthalpy of ionization. Enthalpy of ionization in the sense, in this case, we are going to deal only either atom or molecules. Either atom or molecules, isn't it? Now see, enthalpy of ionization is process. Enthalpy of ionization is concerned. Actually, you studied already in the maybe in the 11th standard. What is enthalpy of ionization? That is the enthalpy of ionization is the minimum amount of energy. Minimum amount of energy required to remove most loosely held electron from neutral gaseous atom and converts into anion. A positively charged ion is called an enthalpy of ionization. It's called an enthalpy of ionization. Suppose A is there, and if it is in gaseous state, and if you want to remove one electron from this A, it is removed. It converts into A plus gaseous by the loss of electron. It is cation is converts. Positive charged ion is converted. So it is the process in which there is the removal of 1 mole of, there is actually it is removed from 1 mole of neutral gaseous atom. Okay, enthalpy of ionization is nothing but that is the minimum amount of energy required to remove 1 mole of the removal of electron from 1 mole of neutral gaseous atom to form positively charged ion is called as an, from neutral gaseous atom is called as an enthalpy change in ionization. Enthalpy change in ionization process. Now, as far as enthalpy change of ionization is concerned, now see here, actually what is the process? Or just if I take an example of enthalpy change of ionization, suppose sodium is there in gaseous state, and if it converts into Na plus gaseous by the loss of electron, sodium च्या valence shell मध्ये जो electron आहे, if that electron is removed and it converts into gaseous, in that process heat change occurs is, that is the 494 kilojoule per mole. 494 kilojoule per mole, and the process is called as in delta ion H, and it is plus value. Delta ion H, it is plus value. Okay, it is plus value 494 kilojoule per mole. Means this much amount of energy is to be supplied to gaseous sodium atom, then it converts into 1 mole of gaseous sodium atom is converts into 1 mole of Na plus ion by the loss of electrons. Now here, if you consider positive charge is center at the nucleus, and here suppose surrounding that there is a different shells are there. And suppose one electron is present at the valence shell. So actually enthalpy of ionization in the sense, it is this electron which is present in the outermost shell, we have to remove that electron. So that is the outermost shell electron. And one term is there, that is the gaseous neutral atom. Gaseous neutral atom is very important. Gaseous neutral atom. So gaseous in the sense that in gas phase is very important, because if you consider sodium in the suppose solid state, the solid state मध्ये sodium जर consider केला तर solid state मध्ये sodium चे atoms जे आहेत, these atoms are very close to each other. Solid state मध्ये, so as solid state मध्ये atoms are very close to each other, so there may be interatomic force of interaction. Between the sodium atoms one. And in that case, if we supply the energy to remove the outermost electrons from each atom, then that supplied energy is not fully utilized for the conversion of electrons, for the removal of electrons, because some amount of energy may be utilized to break the bonds between the two atoms. So in that case, there is no exact value of enthalpy of ionization. No exact value of enthalpy of ionization. But if you consider the gas phase, there is the sodium atom. In gas phase sodium atoms are very discrete from each other, separated from each other. So in that case, whatever amount of heat is supplied to that particular atom, it is only utilized to remove the valence electrons one, because there is no what we call as an interatomic force of interactions between the neighboring atoms. Neighboring atoms, it is separate. It is separated from each other. So it is in that case, whatever amount we are supplied, it is completely utilized or fully utilized to remove the outermost electrons. So that's why it is gaseous neutral atom word is very important in the enthalpy of ionization. Okay. So this is all about enthalpy of ionization. Enthalpy of ionization. Okay. Now after that, next point, that is the enthalpy of atomization. Before enthalpy of ionization, one more. If we consider opposite thing, that is the delta EGH, that is the electron gain enthalpy, or enthalpy change in electron gain enthalpy process. Yes, electron gain enthalpy sense means if you consider neutral gaseous atom, and if you add one electron from neutral gaseous atom to external one electron is added one, then in that case, whatever enthalpy change occurs, that enthalpy change is called as an electron gain enthalpy change, or enthalpy change in electron addition process or gain. So when an electron is added to neutral gaseous atom, in that case overall enthalpy changes occur as enthalpy change in electron gain process. Okay, and this electron gain process, if it maximum and more negative, if this value becomes more and more negative, then in that case that particular atom adds electron more easily. जेवढी इलेक्ट्रॉन गेन एंथॅल्पीची व्हॅल्यू जास्त निगेटिव्ह असेल तेवढा तो पर्टिक्युलर ॲटम त्या इलेक्ट्रॉनला इझिली स्वतःमध्ये ॲक्सेप्ट करणार. इज इट व्हेरी इझिली ॲड्स दॅट पर्टिक्युलर इलेक्ट्रॉन वन. अँड लेस व्हॅल्यू ऑफ निगेटिव्ह इन द सेन्स इफ द व्हॅल्यू ऑफ डेल्टा EGH बिकम्स पॉझिटिव्हकडे येत असेल in that case we say that particular atom does not adds the incoming electron easily, means adds difficultly. That's why delta EGH becomes positive. Okay, that's why S block elements are considered केला तर S block elements delta electron gain enthalpy becomes less negative or either positive. But if you consider the P block elements one, then in that case electron gain enthalpy of P block elements are mostly negative. So this is electron gain enthalpy. Then next, that is the enthalpy of atomization. That is the delta atomization H. Enthalpy of atomization. So as far as enthalpy of atomization is concerned, atomization in the sense, yes, that is the from molecule atoms has to be separated. So best example, suppose if methane is there in gaseous state and converts into carbon gaseous state plus 4 hydrogen gaseous state. So in this process, whatever enthalpy change occurs, that enthalpy change is called as an enthalpy of atomization, and this value is found to be plus 1660 kilojoule per mole. Means this is the enthalpy change when one mole of gas phase molecule is converted into its atoms. Then in that process, whatever enthalpy change occurs, that enthalpy is called as an enthalpy of atomization. So all bonds has to be broken here. Carbon, 4 hydrogen. These all bonds has to be broken. 4 hydrogens must be separated from each other. 4 hydrogen. If we write here, suppose this reaction is written suppose like this one. It is a carbon in the gaseous state, and suppose here write twice H2 gas. Then this reaction does not represent the enthalpy of atomization. Remember, this process does not represent the enthalpy of atomization because here twice hydrogen is there. Twice hydrogen in the sense H2 gas and one more H2 gas. These two, that's why twice hydrogen. In the sense, in this case, there is a hydrogen bond still present. In this case, hydrogen bond still present one. Actually, atomization in the sense from that molecule, from that 1 mole of substance, all the bonds has to be broken. And it converts into separate atoms. So 4 hydrogen in the sense, all hydrogens are separated from each other. That's why 4 hydrogen. Means all carbon hydrogen is broken. Here twice hydrogen is not considered as enthalpy of atomization. Remember. Okay. So these are the points that is we covered here. That is about the enthalpy change in physical and molecular changes. Okay. Today, next lecture, we are going to discuss the detail, that is the enthalpy of solutions. Okay. Good day.